polynomial is a sum of terms of the form a times x to the n, where this a, which is called the coefficient, can be any real number and n, which is called the degree of the term, must be a whole number. Keep in mind that a whole number is a number like 0, 1, 2, 3, etc. It cannot be negative, and it also does not have a fraction part. Here are some examples of polynomials. Looking at the first one, 5x cubed minus 4x squared plus x. Each of these is of the form a times x to the n. X is x to the 1 with also a coefficient of 1, so it has a real number coefficient and a whole number power. Pi times x to the 8 is a little bit less conventional, but remember that the coefficient, pi in this case, can be any real number, and pi is a real number, it's just irrational. And this again is an x to the power 1 term. The number 8 can be considered a polynomial term by writing it as 8 times x to the 0, keeping in mind that any non-zero real number taken to the power 0 is equal to 1, so putting an x to the 0 on this term doesn't change it. Also, just the number 7, which also could be thought of as 7 times x to the 0, is considered a polynomial. It doesn't have to have a minimum number of terms to be called a polynomial. Even a single term can be a polynomial. This kind of polynomial is called a monomial. It has only one term. A two-term polynomial, like we see right above it, is called a binomial. And a three-term polynomial is called a trinomial. But all of these satisfy the definition of a polynomial. Going to the other list now, these are examples of expressions that are not polynomials. In each case, we can say why it is that they do not satisfy the definition. In this case, the square root of x is not immediately in the form x to the n. And if we did write this as a power, it would be the power 1/2. The power 1/2, it turns out, is the same thing as the square root. And then 1/2 turns out not to be a whole number, so it doesn't satisfy the definition of a polynomial. Same thing for x to the pi. Because pi is not a whole number, this is not a polynomial term. And finally, looking at 1 over x minus 2, even if we change the form of 1 over x and write it as x to the power -1, we still end up with something that's not a whole number power. That -1 in this case would be not a whole number power. So these are expressions that are not polynomials, which helps us to understand the definition of a polynomial. A little bit more language. We said that the coefficient is the number that's multiplied and the degree is the power. So if we look at this polynomial below, we have 4 terms in it. The first term is -8x to the 5th. The second term is x to the 4th. The third term is -2x, and the last term is -3. Each of these has a coefficient and a degree. The coefficient of the first term is -8, the degree is 5. When both of them are explicitly written, it's not very difficult to identify them. Looking at the term x to the 4th, that would be an implied 1 as the coefficient. So this would have a coefficient of 1 and a degree of 4. Looking at the next term, -2x, this is an implied power of 1, whereas the final term, -3, is an implied power of 0. Sometimes these last two degrees get mixed up with each other because in both cases the number is not explicitly written. However, negative 2x has a coefficient of negative 2 and a degree of 1. The number negative 3 has a coefficient of negative 3 and a degree of 0. So keep in mind that the degree is only 0 if there is no variable in the term at all. The degree is 1 if there is a single variable without a power. The degree of the polynomial and the leading coefficient of the polynomial are both determined by what's called the leading term of the polynomial. The leading term is the term that has the highest power. So the term that has the highest power determines the degree of the polynomial. This is a degree 5 polynomial, and the leading coefficient. The coefficient of that term is the leading coefficient of the polynomial.